Hello, and welcome everyone to DevCamp 2021. My name is Chris Tackey. Today we're going to be talking about using SQLite on the Meadow platform. It's a good bet that most of you are familiar with SQLite. It's a well-known, well-used relational database engine. What we've done is we've taken the SQLite native bits and baked them right into the operating system on a Meadow. By putting it right into the operating system, we've enabled the ability to p-invoke into those libraries. That, in turn, allows you to use something like SQLite Net from your managed application. That gives you a nice object model to call into the SQL libraries without having to write actual SQL code. The other obvious benefit, aside from not having to write SQL, is that you have code that is portable across different platforms. So if you write some code for a desktop or a Xamarin mobile app or something along those lines that uses the same SQL database, that code is actually directly portable down to the Meadow. Saves you time, saves you work, saves you debugging. Another major advantage of using a relational database is that your data persists across reboots or brownouts or resets of your device. Resets are quite common in IoT scenarios, so the ability to have data that isn't just in RAM is really important. Of course, you could use just a file, write it with a text writer, something along those lines, but retrieving data from something like that is difficult. It's also really difficult to delete records in the middle of a text file, so a relational database works really well. It's especially good for something like a store and forward service model, where your application is taking data as it's received and stuffing it into a database. Then you have a separate service or thread in the background that is reading back out of that database and forwarding it on to a service or a cloud, something along those lines. If communication is cut, network is down, the service is down for some reason, that store and forward service then only pushes when it's able to, so you don't have any loss of data. No data gets thrown on the floor, and you don't have any problems with data loss if you have a power outage while you have data that's been cached for forwarding during a network outage. Now let's just talk real quickly about the basics of doing data storage, especially to a database. The first thing we have to do is we have to define our storage entities, so the objects that we're going to put into the database. Once we've defined those, we then need to create the store or the database and create tables within that store to hold those entities. Once we've created the store and defined all the entities and tables, we then need to connect to that store. Once we have a connection, we can then do our creation, read, update, and delete operations. Let's take a look at what it means to define an entity for use with SQLite Net. You can see here that I've got a class that is basically just a poke-out, plain old C# object. Inside of it, the important things are that every property that we want to go into the database needs to be public, needs to have a setter and a getter. We also need to define the class with an attribute that is a table. In this case, we actually are giving it a table name that is different than the class name. If you omit that parameter, it'll just use the class name. Another often important thing is to have a primary key. In this case, using an integer primary key, which is set to auto increment. So it'll start at 1 and increment every time we insert. This is important here, so instead of having to look by date time, in order to remove them once we've forwarded them to the cloud, we can just look by ID. So we forward a specific ID to a cloud service. Once it has been recorded in the cloud, we can then delete by that same ID in our local database. This is actually a simplified example of what happens in the Klima application. Let's go take a look at Klima for a moment and see just a little bit more complexity. Here's the actual definition of the entity in the Klima project. We have the class definition with the table attribute. You can see we aliased it, and we have the primary key. But then we have all of these properties. They are not just simple setters and getters. Instead, they use these Meadow units conversions and then convert, for example, this wind speed is aliased down to some of these. So we have a Meadow unit speed here. The database has no idea how to store a Meadow units object, so instead we just store double values. You can see these properties are marked as ignore. That prevents SQLite Net from even trying to put them into the database. And then lastly, we have this indexed date time field. By indexing it, it simply means that these will be put in order in the database so that when we go to retrieve them, it will be faster. Now let's take a look at the next step we talked about, creating and connecting to the store. You can see here that we create a database path and then pass that into a SQLite connection object that returns a database instance, and that instance is what we use to interact with the database from this point on. You can see here we use it to create a table based on our climate reading type. Once again, this is a somewhat simplified version. Let's go take a look at the Klima source and see how we're doing it there. Inside Klima, you can see we have this class that's the local database manager. And this database manager has an instance static property. That instance is what the entire application will use anytime it wants to get access to the database or any data in it. When the instance is created, you can see we make the connection here. What's interesting is this path is generated using the Meadow OS data directory. This directory is not erased during deployment like the root directory. So when you're developing, it's important to use this directory so you don't lose your data every time you redeploy your application. Down here in the configure database method, you see we create the table based on the climate object type. There's also this line here that drops the table. That's purely a convenience thing. You're probably going to want to remove that line if you're playing with this or deploying this. Otherwise, you'll lose all of your data every time the application runs. Alright, now let's go take a look at data insertion. Inserting data is really simple with this object model. You can see what we've done is we have this agent. The implementation is over in Klima, but basically it is receiving events from the sensors and getting data in as a conditions object. This is why we used a conditions object for the database entity definition as well, because we can then call save reading on that database manager. We'll take a look at that here in a minute, but we can pass that condition directly to it and it will insert it into the database. We've also gone here on the agent, we've told it to start updating, which then will trigger that event. An optional item here is you could have a store and forward service that takes data out of that database, forwards it onto the cloud or to some remote service, and then once it has successfully been inserted remotely, go ahead and delete it from the local database. Again, let's take a look at this in the Klima code itself. You can see here in the Meadow app, which is the entry point of our application, right in the constructor, we hook the event on the climate monitor agent. Here we use the local database instance and then call save reading. Save reading over here in that manager does some sanity checks at the beginning to make sure things are configured, and then it calls insert on the database instance itself, passing in this climate instance. And you can see that that instance is just a SQLite connection. And that's a pretty good summary of how you can use a database inside of a Meadow application. Obviously, you can do more, and we haven't shown things like reading, updating, and deleting, but they're very similar operations. You'll be seeing a lot more examples using Klima throughout today's presentations. Remember, it is open source. It's an Apache 2.0 license. The full source is available on GitHub. I've put the link here on the screen. You can also pre-order all of the hardware for Klima, including an anemometer and a wind vane, though those are not required in order to start playing around with the source code. By all means, go download the code, play with it, learn from it, give us suggestions, and tell us what you've done with it. Thanks for your time today.
That was excellent. Chris really understands and knows this very, very deeply, and he was the excellent engineer that was able to bring all this to life. And it's really quite interesting because it is a complex stack, and we'll learn more about this later on. But there is the underlying OS that actually exposes the SQLite database, and it gets the APIs to be bubbled up through Mono, and then you have it's set up nicely to work with SQLite.net. So it's a really big feature, and it's really fantastic. And for those of us that come from the Xamarin background, it's a really nice, friendly API to work with. There was a really great question.
Sorry, I was just going to interject and say that in the early days when I was in Xamarin University and I was learning, data storage on mobile devices, there was actually a SQLite session. And it was all about, just storing data into your device. And now, 5 or 6 years later, now here we are just running SQLite on a microcontroller. So all that knowledge that you already know and used on your mobile apps, you're already able to throw them into your Meadow board.
Fantastic. And Chris, I see you here. Are you available for a couple of questions?
I am.
Wonderful. So there was a great question early on about...
Was it about store and forward?
That's the one. Thank you.
Yeah, I just posted an answer, but basically store and forward, it's not built in. I thought about doing a reference service for it. The challenge is that the back-end implementation tends to vary slightly. So it depends on whether or not you're using integers or GUIDs for identifiers and how you want to push and how you want to delete. We could probably put together a fairly easy reference service for that, but it would not be likely identical for every implementation. Then I think I saw one other one about EF Core.
Yes.
And I actually tried to get EF Core running with this, but the Meadow just doesn't have enough space. EF Core, as with a large number of Microsoft libraries, tries to solve all problems rather than 90% of problems, and so it's too big. It's very large. When we have linking working, I know it will bring down a lot of the footprint of what we push to the device, and when linking is enabled, it's possible that EF Core might work. So it would be worth a try if you're trying to keep code compatibility with other, stuff that you're working on. But otherwise, I don't know. Currently, it will not work. You can push it all down, and as soon as it attempts to create the connection to the database, it runs out of memory and crashes.
So in summary, SQLite.net. It's probably your
In summary, yes, currently that is the way to go.
Fantastic. I'm going to show one thing really quickly here as well. I'm just going to share my screen and just show you all that there is a really great example of using SQLite, of course, in the Klima Meadow Pro source code as well. And you can see all for those of you that are familiar with it from other platforms, you'll see the familiar things like creating your SQLite connection. And you can see where we're actually creating the database on the file system. Again, that file system unlocking a lot of capabilities. And then you can see some fantastic examples of actually creating tables based on all objects.
And important to mention, and I had mentioned it in the talk, that path, use the path that is in there, that data directory, because it does not get erased on deployment. If you put it right in the root application directory, when you deploy your application again, your database will get wiped out. So just as a word of warning, because otherwise you'd be like, what happened to all my data? Yeah.
So if you want a persistent database.
Chris, and what happens if I want to update my data model? I want to add a column. How would that work? Is there a way I can just delete my existing table to recreate the database?
Yeah, you can do a drop table. In fact, right there on line 37, drop table will delete the table and you can add it. But the reality is you can, if it's only adding a column and if it's a nullable column, you could actually add it live and it will backfill nulls for all of the existing rows. If it's a non-nullable column, you cannot do that. You would have to delete all data and then alter table, but you can do it that way as well. So it really depends on the schema change you're trying to push.
Perfect.
That's beautiful. I didn't know that. That's great to know.